Everybody, my name's Scott Hebbard. I'm the Communications Manager here at Spark Systems. Good morning, good afternoon, good evening, good night, depending where you are in the world, and welcome everybody to our Sparks Global webinar series that's looking at Enterprise Architect 15. Our topic today is using SysFIS and Open Medallica with Enterprise Architect, and it's a pleasure to have everybody here today. So thank you for joining us. So our presenter today is Dermot O'Brien, and I've worked with Dermot for many years, and it's a great pleasure to have him here today. So Dermot O'Brien, having been one of the first employees at the company, has been with Spark Systems for around 18 years or so, and has a very deep understanding of the product and its application. I'm sure many of you have spoken to Dermot in his many roles at the company. With a background in software development, electronics and audio engineering, this has provided a great platform for working with SysML and the new tools for simulating concepts. So Dermot has a great deal of expertise in this area, and looking forward to hearing him speak and present on the topic. So the agenda for today, I'm going to start off by talking about how to submit questions. We're going to then jump into our presentation from Dermot, where we're going to look at using SysFIS and Open Medallica with Enterprise Architect. We're then going to look at a simulation example where we're going to look at some common electronic circuits being modeled and simulated in Enterprise Architect. And then we're going to hand over to our audience and do a bit of Q&A at the end, and we'll answer those questions. Now, speaking of questions, please note that audio is muted for all participants. You will be able to type questions to the host, so it'll come through to me. And if we can't get to your questions live, I will follow up offline. And we really do appreciate getting feedback on features and products and on Enterprise Architect and hearing from our customers. So it's a great opportunity to hear from you today. With GoTo on the right of screen, you have a questions box. So simply type in the question box there and hit send or hit enter on the numeric keypad, and that will come through to myself as the host, and we'll respond to those questions at the end of the session. But right now, I'd like to hand over to Dermot, and Dermot is going to be presenting on using SysFIS and Open Medallica with Enterprise Architect. So welcome, Dermot, and thanks for joining us today.
Thanks very much, Scott. Hello, everyone. In this webinar, we'll be looking at using the latest SysFIS features available in Enterprise Architect 15.2 beta for doing SysML simulation using the new OMG SysFIS standard. Just as a background, there are numerous engineering disciplines that use simulation tools like MATLAB Simulink and Open Medallica. These include electrical engineering, mechanical engineering, and fluid dynamics. When doing a large design, these often require a combination of disciplines for any one project. So modeling and simulating these can be a complex task. Before the introduction of SysFIS, when you had a SysML model like a parametric diagram or an internal block diagram that you wanted to simulate, you needed to configure the model according to the end application where you were running the simulation. In earlier versions of Enterprise Architect, the model was directly configured for simulating using Open Medallica. So if you have a different simulation tools, you basically needed to create two different models, leaving incompatibility between the two. What the OMG SysFIS specification provides is a means of defining the SysML models that are consistent when applied to these two simulation engines, Medallica and MATLAB Simulink. With large corporations dealing with complex designs, any engineering models need to be contained in a repository that has a clear and tight reference to the design specifications that can be linked down to these parametric diagrams. This is where the simulation tools can be seen in perspective. It's just a complementary interface to a more holistic design that is fully modeled and traceable from the requirements down to the parametric diagram, all contained in Enterprise Architect. To demonstrate this, we'll be creating and simulating a simple digital electronics example that would be used as a part in a greater configuration, all using the new SysFIS modeling. In this case, we will be simulating this in OpenModelica. So on that note, we'll now look at starting up this presentation.
Thanks, Dermot. Sounds great, and I'll get that started.
Hello there, this is Dermot O'Brien here from Spark Systems. In this demonstration, we'll run over using the latest SysML options for simulating digital electronics using the new SysFIS modeling to reference components that are defined in OpenModelica. In this demonstration, we'll run over the following topics. Firstly, we'll have a broad look at setting up a digital model for Modelica. Then we will look at using SysFIS patterns for creating predefined Modelica blocks. In this exercise, we'll use predefined Modelica components. So we will look at modeling complex Modelica components using SysFIS. Then we will generate our Modelica model and run a simulation of this. And finally, we'll look into options for debugging any issue in the generated Modelica script. For this example, we are modeling a simple binary counter using flip-flops, but we will use it to provide a number of divisions of a clock frequency. This type of frequency division was common in, say, an early microprocessor, where you had options for fast and slow clock speeds setting the processor speed. So, what we will use is a digital square wave clock as an input and see how, in our simulation in Modelica, the frequency output from each of the flip-flops in the series halves the initial clock frequency. Okay, before we start creating diagrams and elements, we first of all set our perspective to SysML. This opens the model wizard, which will give us access to get some foundation reference packages that we need in order to work with SysFIS. It's best to create a package to hold both, then select SysFIS and load the two libraries into the package in the browser. Now let's create a block definition diagram. For the simulation, we need to set up a reference to the SysFIS library. So we drag this library package onto the diagram. We first set the package boundary on the block definition diagram to selectable. Then, from the package toolbox, we can create an import connector to reference the SysFIS packages. In terms of blocks for our model, we can start with a SysFIS block for a Modelica clock. This is available from the patterns in the SysFIS toolbox. We select the SysFIS toolbox and drag on a pattern and select the Sources option to find a clock. We see that this is set as a SysML block stereotyped using SysFIS for a Modelica analog clock. However, this is close, but it is an analog clock. What we want is a digital clock. So let's get the correct Modelica path for a digital clock. You can see this under the digital sources. We open the parameter dialog and copy the path. Then we paste that in the Modelica block name. For the Modelica digital clock, it has two key parameters that we need to define on the block: period in seconds and a width as a percentage of the period. So a 1 Hz signal has 50% width and a period of 1. For these, we drag from the SysFIS toolbox the Modelica parameter for period. For the time property, we drag on a Modelica parameter and then use Ctrl-L to set the classifier to time in the SysFIS library. The three other core components that we need to use are also predefined in OpenModelica. These are a flip-flop, a table for setting the logical true state, and a digital output. To create these as blocks in Enterprise Architect, we create a Modelica block for each: a flip-flop, a table, and a digital port. Note that these are set to SysFIS for Modelica. Now we want to set a reference to the Modelica path for these. So from Modelica, we look at the properties of a component and get the class path from the properties. In the case of the flip-flop, we copy this to the sysfis Modelica block name. We then do the same for the table, get from Modelica its path and set this in the model. Then we do the same for the digital port, get the Modelica path and set this in the block. Now we need to set the SysML ports on these blocks. For the flip-flop in Modelica, it has ports JK, Q, QN and a clock, so we need to set these up. The block types for these are defined in the sysfis components package as input and output Boolean signal ports. We drag on the input ports on the Boolean signal and then name them to match these ports on the Modelica component. Then we do the same for output ports using the Boolean out signal. For the table, on the Modelica side, it uses a parameter to set this as a true constant and a port as an output. This is expressed through the port and set as an initial constant. We first set this port on the table by dragging on a Modelica port. Then we set the constant by dragging on a PHS constant. We will set the values for these later when creating the internal block diagram. In this next section, we will create the main block that will contain the IBD diagram. This new diagram is where we connect these blocks as parts to form our flip-flop counter. Now let's create our block for the binary counter. Then we create a child diagram on this block called counter, on which we then drag on our blocks as components. For this, it's recommended to use the All option in the Paste dialog. The first is the clock. We name it CLK. For this, we need to set in the properties the width to 50 as 50%. For the time, we need to set this to 1, for example 1 Hz. We delete the properties to get these displayed in the compartments. Then we create 4 parts of type flip-flop and name each of these as flip-flop 1 to 4. Then we create one for the table to set our true state. Then we create our 4 digital ports on the counter to give us our outputs. We then need to set our connectors between the relevant ports to fit our proposed model. The first is the clock output from the clock port on the flip-flop. The subsequent flip-flop clocks are connected to the preceding QN. We then set up the J and K ports to true by connecting these to the true table. Also, we have to set our digital outputs from the Q ports. Now for our table, this needs to be set to pass a logical 1 or true state to our J and K ports. Firstly, we just set the name to true. Then we need to set a Modelica parameter for Y0 that sets it to logical true. For this, we open the Modelica properties and select a true state, then copy this path to the initial property in our Y0. Having set this up, let's now configure our simulation. We start this by creating an artifact of type SysML sim model. Double-clicking on this opens the simulation configuration. Let's select the package to simulate. A point to check before starting is that the Modelica is selected and that our connection to Modelica is configured. Ensure the Modelica library is referenced. Set the parent block for the SysML model that we are simulating. In this case, it is the counter block. We set this as SysML sim model. Now we see the list of properties available to plot on the right. So we select which of these we want to plot. Now we run the simulation. The plot in Modelica is complex. So let's simplify this. We see the simulation of the clock frequency being halved for each flip-flop that it has passed through. And of course, let's have a look at how this internal block definition diagram is generated out into script, which when opened in Modelica is shown in its diagram format, which corresponds to our SysML diagram. We find the script that EA has generated and use the context menu to open it in Modelica. Here we can see the components that we created in the SysML model as shown in the Modelica format, along with the connectivity we set up in our SysML model. We can now run a simulation directly in Modelica and see how it generates out our plot. When doing a complex diagram, there are bound to be issues with the generation of the plot. So, on that note, let's have a look at the debugging and issue resolution when generating to Modelica. Firstly, we set up an error. We do this by setting a wrong connector to the block, not to the port. Now when we rerun the simulation, we can see that there is an error created in the build, viewed in the system output. If we go to the Modelica system output, we see the error that it generated. If we double click on this, it opens the script at the line where the issue occurred. In this case, we see that the connector was the flip-flop, not one of its ports, as can be seen in the connector below to a K port. An alternative issue checking method is to open the script file directly in Modelica. Then view the diagram and check the connection. Then you can run the simulation and view its error and see that it is a connector issue. Given this feedback, we can now do a simple correction of the model and then we can rerun the simulation to see that the issue is resolved. Okay, so in conclusion, let's run over what we have covered in this demo. This included setting up a digital logical model for Modelica by using SysFis patterns for creating predefined Modelica blocks, modeling other complex Modelica components using SysFis, generating a Modelica model, then simulating and viewing this in Modelica, and finally running over how to debug an issue using the script or viewing the generated model in Modelica. Although we have focused on using Modelica, please note that a similar scenario can be replicated using the SysFis for MATLAB. Hopefully this gives you a good starting point for getting familiar with the integration and simulation with Modelica as part of the new SysML SysFis features available in the 15.2 release of Enterprise Architect. For more information on this, see sparksystems.com/EA152.
Okay, thank you very much for that presentation, Dermot. That was very comprehensive. I just muted your microphone before because I could hear a little bit of feedback. So can you hear me, Dermot?
Yes, hello Scott. Thank you.
Very good. So we've just got a few questions. I might just start off with the first one. A couple of people have asked about the actual model that was used and if they wanted to be able to get access to it. So perhaps you could talk about whether that model will be made available and whether people could use that in their own home usage to test out the new simulation features.
Yes, well, we certainly do have a model there available. I've got a digital example in it as well as an analog example using an op-amp, and we'll make that available on the web page. And also, if you wanting to sort of contact me, you can do that through our support email, and just send me a link and an email, and I'll pass on some details of how to get to it.
Excellent. Thanks, Dermot. One of the other things that was shown was Enterprise Architect 15.2. The features that are shown today, is this new? Like, can it be used with Enterprise Architect 12 or 13? Would you be able to comment on that, please?
We did have parametric simulation with OpenModelica in earlier versions. I think that might have been about version 14, 15. We did have them available. This new one, which includes the SysFIS, is part of the Enterprise Architect 15.2 beta build. It's yet to be released, but it is available as a beta for download.
Okay, so following up on that, if people want to go to sparksystems.com, so www.sparksystems.com, they would be, if they're registered users, be able to download that beta and try that out today and test it. I've got a question here from Michael. With this working on Modelica, is this possible using Wolfram System Modeler? I'm not quite aware of that product, but would you perhaps just talk about you know, Simulink and OpenModelica and you know, what options there are available for people? Damn it.
Yes, well, the two key products that we are supporting at the moment are OpenModelica and the MATLab's Simulink and Simscape. The OpenModelica one is fairly it is fairly well constructed for the beta release. We have quite a bit of stuff going there with the MATLAB, being able to use the Simulink, but some of the more obscure sort of components and things like that we've yet to kind of resolve. So it's still in being constructed, but it's definitely available for some of our key examples. We will have some example models available for using that as well. We are not aware of it. Well, I'm not aware of these other products, but it certainly would be interested to have a look at what equivalent ones are available. So,
yeah,
you know,
I think our questioner says Wolfram also produces Mathematica. I think at the moment we are supporting these two. OpenModelica, obviously OpenModelica is free to download, and Simulink we're using as well. So that's great. So the next thing I wanted to ask is what are some of the benefits of actually using Enterprise Architect with OpenModelica? So could you perhaps, Dermot, mention things like traceability and documentation, and what are the advantages of doing your modeling in EA, but you're simulating in something like OpenModelica?
Yes, well, as I was sort of saying in the beginning of the presentation there, it's if you these sorts of tools are really good for being able to kind of graph things and be able to do a plot on the likes of that. But when you're doing a very large project, you know, like when you're doing sort of aerospace type stuff that I remember doing a previous example in which we were doing a lunar lander with this sort of with using OpenModelica and basically doing the plot on that. But when you're actually talking about designing a you know, full sort of a space type thing like the lunar lander, you'll need to have your requirements and traceability of everything from the very top right down to your classes, to your code and things like that, all being consistent. You want to have them linkable and traceable. And that's why, you know, there's so much better to be able to model it all, especially when you're looking at sort of systems engineering type of things, that you want a model-based design and have that all linkable within the model. And then just be able to use this as a peripheral thing to be able to do your plotting and be able to view it and test your design from that.
Yeah, thanks, Dermot. I think it's a point well made that all of the requirements, the traceability, the documentation, the modeling, and the connectivity is all handled within Enterprise Architect, and the mathematical models, the simulation, and the graphing is done by Open Medallica. So each tool has its strengths, and you get to leverage those strengths by combining the two. I've got a question here from Frank that just says, is it possible to reverse engineer an Open Medallica model into EA? So let's say someone comes from a systems engineering background and they have a model that they've set up within Open Medallica. How could you then, perhaps pull that into EA?
It's a very interesting question. We have had a bit of a contemplate about that one. It's definitely possible, but really at the moment, what we're sort of dealing with this is more making this as, dealing of working from the model-based design down into these products as opposed to doing it in reverse. But in theory, yes, you could do that. I mean, we do have the facilities within Enterprise Architect to reverse engineer code and things like that. But no, we haven't actually looked into doing that as yet.
Excellent. Thanks very much, Dermot. So, look, I think what we wanted to do today was to be able to show these new tools, to show the integration. I would encourage all of our audience to go to the Spark Systems website and to download that, to download the Enterprise Architect 15.2 beta and to try these things out. And of course, you can contact webinar@sparksystems.com if you have any questions, or if you have any follow-ups that you would like to pass on to Dermot and the dev team about how it works and how to get it up and running, and we'd be more than happy to help. So Dermot, thanks very much for your time today, for showing us this example. It's great seeing it modeled in EA and getting the plots generated in Open Medallica. Looks great and looks fantastic. This webinar will be made available on the Spark Systems YouTube site in approximately 24 hours, and we'll try to get this video and the Q&A up on the Spark Systems webinar site within a few days once we get the questions answered. So I'd like to thank everyone for their attendance and for their time today. Thank you very much, Dermot, for your presentation. It was great to see it in action. And with that, we might wrap up the session. Thanks, everyone. Take care, look after one another, and be safe. And we appreciate you taking time out of your day to come and hear about Enterprise Architect 15.2 and the products at Spark Systems. Thanks very much and have a fantastic week.
Thanks, Scott. Cheers.
Thanks, Dermot. Bye-bye.